This is a production of Cornell University.
It's going to be an interesting ride today, being 35 plus years at Cornell. And so the title is it just grass? Well, maybe it was working. Okay, now it's not. All right, we'll go this way. We were having that work. Or maybe it's a little more, and that's what I want to, I think that's my take-home message. When I look at turf and turfgrass areas, I see them from a slightly different perspective than maybe you might. And so that's what I want to share today. And I'm not talking about this kind of grass. You know, it was always the laughter in my family, or I meet somebody, well, what do you do? I said, well, I work with grass. And so the snicker is this kind of grass? I said, no, that's not even a grass. But at least it's more like this kind of grass that deal with golf courses and lawns and sod farms and athletic fields and commercial grounds like campuses like this, airport strips, roadsides. I mean, anything that's using grass species that are routinely mowed for all kinds of reasons and all kinds of functions. And so what I'd like to go over today are some of the kind of functions that we use turf grasses and in landscapes as well as part of landscapes. And so there's an aesthetic component, a financial component, a recreational component, and the last one that I'll actually show a bunch of data on is ecosystem function services for turfgrass and landscapes. And so we can't deny that you have these beautiful grassy vistas that, in this case on Eastern Long Island, a golf course, or a beautiful sports field. Well, maybe this is not that beautiful. I got this picture, I'm there. How do you play soccer on that field, you know? Or you have a little sneak attack over in those shrubs to the bottom left there. And that would be an interesting one to maintain as well as kind of play on. That would be a 1-0 kind of facility. But more like a sports field like this, like Yankee Stadium, that Frank's not here today, but Frank has been very instrumental in working with Yankee Stadium over the years. But I'm from Pittsburgh, so the PNC Park for the Pittsburgh Pirates, at least the team that made the playoffs the last 2 years, unlike the Yankees. Yeah, I know, to kind of rub it in just a little bit. But a lot of times we think about golf and sports turf is like the big thing of turf, and they are the visible things. They're on television, you know, articles written about them and whatever. But there are a lot of kind of other uses that we might see. So you can see grasses used at art form, and we know Marsha Shively has done a lot of kind of sod-related projects from an art perspective, and her students have done some really cool things with grasses. But a lot of times we think more of the traditional version of a landscape that we see in suburban areas where you have a green carpet adding to the value of this landscape that we see there. And so one, it may be a visual thing, you may enjoy it, but also there are some financial implications. And there have been a number of surveys looking at the economic value of landscapes to the property value itself. And so landscapes can add as much as 7 to 15% to the value of a home. So a poor landscape would get you less if you were trying to sell that property. And so Clemson did a study showing that homes with excellent landscapes, you can expect the sell price to be 6 to 7% higher than an equivalent good landscape, and while improving your landscape from average to good, you could even see a result of 4 to 5%. So there is an economic value to even though there is a visual effect to these kind of landscapes. Now you may not have known, so I'm going to throw some facts out, how large the use of turf grasses are, say, in the U.S. And so a study done in 2005 estimated there were over 30 million acres of maintained turf in in the United States. And if we come a little bit closer to home, New York State has 30 million land acres. Now, if we added all the water and whatever, New York State is bigger than that. But New York State has 30 million land acres. So all the turf that's in the United States is bigger than the land area of New York State. Within New York State, there are over 3.4 million acres of turf grass, accounting for, from 2003 figures, $5 billion per year in maintenance costs, mostly on residential properties. That's about 70% of the land area. About 43,000 workers with an annual payroll of at least $500 million done by the New York State Ag Statistics Service, not an industry group, as some people always like to point out when you have surveys done. Well, you're just inflating these figures. This was done by the New York State Ag Statistics Service. But there are a lot of recreational things. If we get away from the beauty, the financial value, there aren't too many surfaces, natural surfaces that we have that you can recreate on constantly and have it be left. And Frank, we're here, his daughter's actually in this picture. That's why one of the reasons I like to use it. And it's from Trumansburg too. That's some of our fields there. So if we look at this, there really aren't other natural surfaces that can take constant wear and traffic, soil compaction, can be mowed closely. Those golf course settings, a putting green can be as low as 1/10 of an inch, harvested every day. There aren't too many agricultural systems we harvest that low and that frequently, and hopefully something will grow as part of that. But we do have some imposters to this, and one of them, we have an example across the street, this Greenus ficus that I'd like to call, is we have a synthetic turf across the street, and this was taken 2 weeks ago. They're out there irrigating the synthetic turf across the street. You know, it's kind of very ironic that you would think in late October we're out irrigating. Well, it's done to control the speed of that surface for the ball roll that the field hockey players, the women's field hockey field. So even with artificial surfaces, you do need to do some kind of maintenance, including irrigation to some degree. But what I'd really like to cover today is to talk about the ecosystem services you could get from turf grasses and other suburban landscapes in that context. And so there is this, however, if you're trying to talk about positives having ecosystem services, are there negatives related to these kind of land uses? And so there has been shown, and I'm not going to show data, but there's been a number of studies shown that water quality in suburban areas can be compromised. And it's usually the two things that are compromised is phosphorus levels tend to be high. And if we were going to compare it to an agricultural setting, those phosphorus levels may be higher in surface waters than in agricultural areas. Nitrogen levels are actually lower, and I'll show some data, probably the reason for that. And are also pesticides that are used in landscapes in these suburban areas that have compromised water quality. So from that, there have been restrictions at both state and local levels, either restricting the type and amount and season of application for pesticides and fertilizers, mostly fertilizers, and banning pesticides. If New York State has a ban on school ground pesticide use, unless there are some very limited ones you're able to use, or you can get an emergency exception to it. And Jenny Galniffin's been doing a lot of work with that because many of the problems we have on school grounds are weed related, and trying to manage weeds without the traditional herbicide approach becomes quite difficult. So that's been one of the parts of this, is we have seen regulations put in, and those of us, I mean, I work in the political end, and restrictions are made by politicians, not by scientists. And quite often, I think if they really understood the science behind what they're trying to regulate, they might have done something differently. So as an example, New York State has a ban on applying phosphorus to turf areas, except for a couple ways. One, if you're establishing a turf area, you can put it down, or you take a soil test and there's a need for it. So those are the kind of two exceptions to it. The problem is the first one is, and we will show you data, that if you were going to be putting phosphorus down at the time of establishment, you have very little plants there to hold on to those nutrients, nitrogen and phosphorus, and runoff and leaching can be pretty significant. As a matter of fact, that's the worst time when we look at all the studies done on the fate of fertilizers and turf. That's the worst time environmentally. So the regulators should have said, do a soil test to see if you need phosphorus at establishment, and even that, be careful what you're putting down. But they just gave a blanket exception because there was a law passed in Minnesota, there was one in Wisconsin, so New York legislators were smart enough just to grab those and probably not take the advice of people like me who wrote to them and asked them to consider not putting that in there. We do need phosphorus at establishment, but if the soil's already adequate, and it doesn't really do you very much good. And then so from that, are there positives ecosystem-wise? I wouldn't say to counteract, but what are the benefits we might see, ecosystem function benefits? And I think we need to always evaluate that in a landscape scale setting. So this is one thing that EPA put up several years ago. Make sure you keep your fertilizer on your lawn, and I think that's a great idea. And if you kind of go down there is some stuff that talks about how to manage turf, and we've I've done a lot of research over the years, and most of it I'm not going to be showing today, that are used to try to help improve the management of turf to minimize the environmental impact. And we've spent a lot of time and effort trying to do that. But what I want to cover today is kind of three parts of ecosystem services that we've had graduate students, and I'm mostly giving my own graduate students data today, at looking at what you could from a turf landscape get what benefits you might get. And one large one we have found, and other people who have been studying this, is that stormwater amounts, the runoff amounts, can be significantly lower in a turfgrass area than they can in other types of landscapes. But it's really based on the landscape type and the plant density and to some degree age of that site. And the second one has to deal with soil phosphorus and phosphorus runoff. And you might say, what kind of ecosystem services is benefit from that? And I'll tell you later, because that is one of the sections. And the last one will talk about carbon and nitrogen sequestration, which is a big thing these days in most ecosystems. And what do we know about turf in that context? So the stormwater one and runoff, I'm going to talk about in relationship to loading rates based on landscape type and plant density issues. And I've been fortunate over the years to have a number of great grad students. Zach Easton did a master's and a PhD, so this was his master's work. He's currently down at VPI, and I just saw that he won the Outstanding Assistant Professor in the College of Engineering. So I didn't know I was training engineers, but Zach went on to do very many great things. He was here as a postdoc in biological environmental engineering for a number of years, and then took a faculty position down there. He was a turf guy, you know. It's amazing to see where some of your grad students go. So what did he determine in his master's? And this is a slide showing plant density on the bottom, shoot density, and on the left you have the amount of runoff, and on the right the infiltration rate of that soil. So as you double the shoots, going from 5 to 10 shoots per centimeter, you cut the amount of runoff by 2/3. And the reason you do that is the infiltration rate doubled over that period of time. And so this kind of tells us several things. If for some reason you lose plant density or don't have a very dense surface to begin with, runoff can be a major issue. So this was done during an establishment phase, the first 3 months of when these plots were put in. This graph was put together. So this helps explain why I have this concern over when you're putting down fertilizer and there's no plants there, what do you think is going to happen? Well, the chance for runoff can be quite significant. One, the volume of runoff, erosion, and also what might be in that runoff water. So sites with low density, including established, really have been shown in this study and a number of other studies to pose the greatest risk to runoff. Once it's established, as we'll see, there isn't as much difference depending on the landscapes there, as long as you can maintain density. So Zach went on to do a landscape scale, and this is what started to get him into the engineering part, environmental engineering, looking at landscape types in a suburban area and the amount of runoff and its effect on a perennial stream going through there. So I had two PhD students working on Zach Easton's PhD and then Mark Slavin's after that, with looking at a slightly different study. So Zach's work was done in the northeast section of Ithaca, going from Convenient Care on Warren Road to Kendall on Triphammer. That's subdivision in that area, and that's what this illustration shows. This is the watershed that stream is affected by, and the watershed, the head part of that watershed, is actually the ornithology lab and a lot of wooded areas up there. And so if we kind of look here, this is basically his study area down, but this perennial stream flows through there, and he had a gauge here, kind of looking at the inflow from the area above, and then the stream gauge below that measured what happened during that area of suburbanization. So if you've ever driven through that, it's a typical subdivision, homes built in the 50s, 60s, and 70s for the most part. It's a perennial stream, and so he looked at basically 3 different landscape types, and there were 3 replicates in this study. So let me go back. He had the upper part of this watershed. The numbers will be 1, kind of the mid part of this watershed, 2, and the ones with 3 behind it are the lower part. So this is higher elevation, lower elevation, and there's a big difference in that watershed, the location of that watershed, what might happen with that. So we looked at 3 different types of residential landscapes, suburban landscape, a high maintenance lawn, convenient care, Kendall, all commercially maintained. We didn't have any control over what they were doing, but we knew what they put on. It wasn't something we defined. Matter of fact, we probably, knowing after we did soil tests, the soils levels were adequate in phosphorus, they still put phosphorus on. But we didn't want to, so we just want to look at real landscapes. These are real sites, not research, typical research plots. He had low maintenance areas that were primarily grasses, mostly mowed. One of them was not mowed at all. And the other was comparing a suburban wooded area, a deciduous tree area, and looking at runoff and what was in that runoff on this site. So Zach this was a 3-year study, so this kind of shows the 3 different areas, a high maintained turf, runoff collecting area, the low maintenance area, and a wooded area primarily with deciduous trees with the litter drop from those trees. Anytime there was an event, a runoff event greater than 1/10 of a millimeter, they were collected. And on some of the plots, there were 127 runoff events in 3 years. And he measured dissolved reactive phosphorus, nitrate, ammonium, and then be able to calculate mass loss, knowing the volumes of those areas. And so I just wanted to show this as a summary, mostly to tell you about season and 2 things. But first is the amount of runoff in the first 2 years in the highly maintained turf site compared to the wooded and low maintenance area were significantly less, 1/3 on this area compared to this low maintenance turf, and about 2 times less with the high maintenance turf area compared to the wooded area. And the reason is that type of dense plant vegetation, a tremendous amount of surface rooting and root activity, earthworm activity, high infiltration rates, runoff is significantly less. Now, if I were a stormwater management person and I didn't put labels on this and you showed me these things, I said, well, what landscape would you want to reduce runoff in stormwater management? You definitely would want something like that. So this is a benefit that we don't always think about in these landscapes, but it's a very significant landscape effect.
This is the creek that runs a little bit to the south of Kendall.
It goes through Kendall.
Yeah, and
it crosses.
Through
Yep.
that residential area.
Yep.
It's a little creek. Right?
It's a small stream.
Yeah.
It's a perennial stream.
Yep.
And very flashy, which it reflects runoff. So if you get a little bit of precipitation, there'll be runoff. And so that stream is a very good stream to study runoff because it does quickly show what can happen in that stream. Yeah, it's not a very big one. It was an interesting place though. Okay, this is a very busy table, so I'm going to try to kind of walk you through it. Again, we had these 3 zones within that watershed. The 3s were the lower end. The ones, as we will see, had the greatest amount of runoff, the most runoff events, and the amount of runoff occurring on, this is an average amount in each one of these runoff events. This middle section and then again on the upper end had the lowest amount of runoff events and the amount of runoff occurring. So I highlighted the ones that were significantly different. So in runoff, we had dissolved reactive phosphorus, either the concentration on average, this is the average concentration coming out of those individual events, and then the total load of phosphorus coming from that. So we could see in this lower part of the watershed, where there was the greatest amount of significant amounts of runoff, we could see the fertilized turf areas compared to the unfertilized or forested area, I really want to call it a wooded area, were significantly higher. And the total phosphorus concentration was also higher, and the load was just significantly higher than only one of the 2. If we look at the middle and upper parts where the amount of runoff was significantly less than those 2 areas, both in amount and and the number of events, we could see that we could see less phosphorus runoff in the load of phosphorus runoff in that area, or at least relatively equal in the upper end. The dissolved phosphorus ones, we could see there were no difference between these landscapes, or if there was in one case it was slightly higher, but the highly maintained turf was actually less in that case. And what Zach has concluded in this case, that if we kind of look at these sites with low to moderate potential for runoff, and a watershed like that is actually this is a very good kind of watershed to study that. High maintenance lawns had the same or lower amount of dissolved phosphorus, total phosphorus runoff compared to the unfertilized turf areas or the wooded sites. But the issue was, however, when you get in these high potential for runoff sites. We did see with the high maintenance lawn there was an increase in the loading rate of dissolved phosphorus, likely from fertilizing. But there was a quarter of the amount of the particulate phosphorus loss, because we also measured in the sediment that came off of those plots. So there was a reduction in that. And again, that reflects back to high density area that increases infiltration rate. The amount of particulate or erosion was significantly less. And then the same amount of total phosphorus in the runoff compared to unfertilized and low maintenance areas and wooded sites. Total P being slightly different than the dissolved P. Usually dissolved phosphorus does relate back to fertilization in many cases. So what happened in that stream over this study? And it was kind of an interesting thing. You might think that suburbanization is likely going to do something. It was shown that suburbanization in that suburban part of the watershed, that the outflow, the stream had the same level of nitrates, had higher ammonium levels, likely from the fertilization that was occurring. More dissolved phosphorus during storm events, not during kind of base flow of that stream, and higher particulate loss, quote, erosion than the undeveloped section of that watershed. So it is interesting to show that as we kind of showed in the introduction to this, that you can see suburban areas being a source of phosphorus, and fertilized lawns, if you have a part of that watershed that's in a higher risk, are more likely to have an impact. If you have areas with really moderate to minimal runoff losses, the landscape itself has very little to do with what might be coming off that area. Okay. So the second student that kind of followed on this was Mark Slavens. He was looking at a little different version of landscape types and runoff, and actually in leaching. And now Mark is Vice President of Environmental Affairs with the Scott's company, and has been actually very good at supporting us. It's nice to have somebody in these companies when you need seed and fertilizer, and they're making some significant contributions to some projects we've had. We'd like to get some research money on them too, but it's nice to actually get some product too. So his objective in his PhD work was to try to determine the relationship between lawn density and composition on nutrient and pesticide loading. And he had basically 4 kind of grass type, perennial grass type lawn treatments, and 4 sometimes perennial but non-typical kind of grass lawn types. And so he had one with Kentucky bluegrass, and what we did is basically had 4 of these that were initially sodded with Kentucky bluegrass, so you had nice plant density to start with. One that after that point all it did was to get mowed. One that we added fertilizer to, fertilizers and pesticides, fertilizers, pesticides, and irrigation. So going from intensity of minimal maintenance other than mowing to the most intense one where we're adding even irrigation into it. And so basically we put on, as it turns out, a program very similar to what Scott's would sell you in a 4-step program for your lawn. So there were 4 applications with fertilizer, and these were the pesticides that were in those to control broadleaf weeds, and insect and annual grassy weeds. So that would be something if you went down and bought a typical program, this is what you might see for a typical lawn, high maintenance lawn. So the other set of treatments involved either directly having other kinds of weedy material in there, smooth crabgrass, and smooth crabgrass with half turf. So we plugged out half of this area, and I say I didn't do that, but Mark and my technician Jeff and helpers did that. So that you had a 50%, at least initially, 50% turf grass, 50% annual grass. And the annual ones, these were just seeded each year to try to keep those in there. A broadleaf weedy one that had very high broadleaf, very high density in it, and then one that, again, we plugged in Kentucky bluegrass sod initially at 1-to-1 weed, broadleaf weed to grass, and there were 4 replicates of these treatments. Okay. So we wanted to do a typical kind of residential suburban type installation. So the bulldozer was brought in, removed all the soil, brought back, and compacted with equipment like this to simulate what you do when you build a new site, and the topsoil was put back on it. We did two sets of types of collections in this study. We had these 2 by 3 foot lysimeters pushed in the ground, pulled out, a PVC bottom put on, and a drain line coming out of those, so all the water that would be infiltrating through the soil and leaching out would be collected. Those are on the upper surface of these plots, and the slope is about a 9 to 12% slope. We would put a gutter collecting system so that all runoff events coming from those areas. So you can see this is crabgrass, not very much there, the perennial broadleaf weed area, and then the straight Kentucky bluegrass next to it. This is what they look like at establishment. So what did we find from a leaching perspective? We found that this is the volume of leaching occurring over a 2-year period, that except for one kind of plot, most of them had a similar amount. Over that period of time, there were about 1,100 millimeters of precipitation, and we can see that we're seeing about, some of these ones, about a third of what the precipitation ended up leaching through the soil, which is actually a pretty high amount as compared to some other studies. And so what did things like nitrate look like, concentration? And a lot of times, so this is the nitrate mass loss over time. And if we kind of look up here, this highest one up here, okay, it's the one with 1 dash. Mark made these slides, I didn't. I would have probably made a little bit different version, so it may be a little bit easier to read. But we can see, and these are approximately samples taken monthly, bulked together monthly, and then analyzed. And we can see that the worst one in this case happened to be the one that's, at least comparing the turf ones, the one that was turf with nothing else added to it. And as we can see, the one with the highest, kind of after that, tends to be the turf with fertilizer, and a little bit less with the other ones. Then after this kind of establishment, even though these were sod, after this establishment year, there were a couple peaks later on, and it reflected, sometimes some treatment was slightly higher than the others, but there was always a baseline amount coming out of these, and sometimes ones higher, especially with irrigation, and we'll certainly show that in runoff. So that's what nitrate leaching looked like. Now at the other plots, okay, the ones mostly with weeds in it, the scale of these are the same that we saw before. I'm not skewed. Sometimes you can I wouldn't say skew different things, but the scale of the data is the same in these curves. So we can see some of the worst ones that we saw were similar to before. It was this first year peaking either, say, the second set of samples time back to about the end of the growing season, if we were kind of looking at periods of time. And we can see that crabgrass and crabgrass with turfgrass in it, especially the crabgrass and turfgrass one, had losses similar to what we saw with the ones that with fertilizer fertilized up. These weren't fertilized at all after they were established. Okay. So if we summarize the kind of the losses in this, if we look at that, the greatest loss, we saw very little ammonium loss. And this is typically we see in turf studies that we don't see much ammonium leaching. Even if you put ammonium-based fertilizer, it gets converted to nitrate pretty quickly. The greatest loss was with nitrate and a little bit of organic nitrogen coming out. On an application basis, the one that we put on that had turf with fertilizer, it was equivalent to about 1.8% of the nitrogen that was applied leached through that system. And it was the only one that was significantly different than other treatments was the broadleaf one. It started low, it never really had anything leaching out, nothing was applied to it, and it didn't change over time. And actually these tend to stabilize over time. So the kind of take-home message tends to be that a dense perennial system, whether it's with grasses or broadleaf weeds, are pretty good. So this is phosphorus, this is runoff, and the total amount of runoff that occurred over the 2-year period. And again, if we look at these numbers, we were seeing 400 millimeters with leaching. We're down to about 100, so only about 1/10 of what came on as precipitation ran off these sites, which is relatively, I would think is relatively low. Even though it's a very slopey area, these are relatively low. We could see that areas with turfgrass with fertilization tend to get the amount of runoffs less than some of the other treatments, especially if we compare it to crabgrass, which was the worst. But when we even though we put fertilizer and pesticides, when we irrigated that, we see the amount of runoff jumped up pretty significantly. And the reason that occurs, it wasn't the irrigation itself creating runoff, but it keeps soil and seed moisture content higher, and then any precipitation can more likely run off. And so there has to be a caution, I think, in areas with irrigation. You run the risk of keeping soils more likely to produce runoff. So that's just the volume of runoff that occurred. So how about the amount of, in this case, phosphorus in the runoff, as well as nitrogen and ammonia? There was a little bit of ammonia, not related to treatment. There was some nitrate, again, hardly relationship to the treatment, but there was slightly higher amounts of phosphorus in that runoff, but relatively small on the amount that was actually applied. So we could see going from turf itself with fertilizer, with pesticides, for some reason with pesticides saw slightly higher amounts of nitrogen running off, and with irrigation we didn't see, we saw slightly less than what we saw there. But again, the amounts are relatively small, and that all landscapes lose some. And this is what has always been my pet peeve. People say, well, let's just let it go. Is it going to be better for the environment? There's always some loss out of these systems. They're not 100% at retaining nutrients. So Mark concluded from this, regardless of the plant type, low plant density and high seed moisture content were the greatest factors affecting runoff volumes. And so the need to maintain a dense canopy is very important. Perennial canopy is very important. An annual one, you could have crabgrass being very dense in August, and once the first frost comes in September, October, November, whenever that might be, you start losing plant density, and those areas become quite leaky and likely to show problems. And he also concluded that the ammonium and phosphorus losses in runoff were low, but increased with time. They were occurring. The relative amounts were relatively low. And overall nutrient loading, runoff, and leachate were less than 2% of the N and P that were applied. Because I've seen laws written around the fact that we see 25% loss of fertilizer applied to turf areas. Massachusetts is a very prominent one, likes to write land use laws around that where there's no data to ever back it up, which again, as a scientist, you tend to get a little upset when you're making laws that aren't based on facts. Okay, so the second one of the ecosystem service stuff I want to talk about is soil phosphorus and phosphorus runoff. And you might say, what the heck does this have to do with ecosystem functions? Well, this was done with Doug Soldat, did his PhD. He's currently an associate professor at University of Wisconsin in Madison in the Department of Soil Science. Went back to his home department. So what's it have to do with soil phosphorus and phosphorus runoff from turf and an ecosystem service? Well, one of the things and actually I got grants to do this, was to look at turfgrass sites as a potential for taking compost, especially animal-based compost, to remove that from a farm that has excess phosphorus because of importing all the feed, so they can reduce their surface phosphorus water quality problems and put on a large landscape like turf. And we also see there's a lot of interest in using massive amount of yard waste compost in turf and residential areas as a way to get rid of those as well as reuse those materials. So there could be, if you can retain all this phosphorus in that system, that might be a great ecosystem service. You don't, then this would not be a very good system to do. So we looked at, Doug looked at first taking some long-term soil nutrient calibration sites we had worked on, putting phosphorus levels at different amounts on. And these were 4 sites all across New York, going from the Adirondacks to Long Island, that are fertilized at typical fertilizer rates, not something that would not be typically done. They were about twice as much of what the soil test would require, but probably within more traditional range. And so in these sites we had, Doug did 2 things. One, he removed the soil and removed the turf that was on it and looked at the runoff that occurred from that. So this is soil test level on these individual plots versus the amount of phosphorus in runoff, the concentration in runoff. And so without turf there, you see a pretty consistent increase as if you increase the soil phosphorus level, you're going to see a corresponding increase in the amount of phosphorus in runoff. And that's pretty typical of kind of typical kind of bare or annual cropping systems, where you can see a pretty consistent and a very useful tool then to look at reducing phosphorus levels to make sure you don't have excess amount of phosphorus in the soil, but there was this relationship. But what happens on the same plot with actually turf on it? And the turf would be growing, and see what that impact would be. So in this case, the exact same plots with a dense turfgrass on them, we see kind of no relationship between soil level, at least in the range where we're raising phosphorus levels from typical applications, and the amount of phosphorus that's in that runoff. So when you kind of look at this, where again the New York state law and many other states, they do a soil test, and if there's adequate amounts on, don't apply it. Well, our recommendations are down here at 4. If you have 4 or more pounds of available phosphorus per acre, that you have sufficient, you wouldn't need to put an application on. But you can see that could be significantly higher than that and not really see any major environmental impact. Now, are there situations, however, that we see soil levels get highly elevated from phosphorus? And one of them is back to this question of using compost on turf and in landscapes. And I want to kind of expand it to the landscape ones. In turf areas, we quite often, if we're going to apply compost as a soil amendment, we're going to put a fair amount on, a 1/4 or 1/2 inch material. In this case, we did it with a dairy compost. And I'll show a slide that you work it in, and that's on established turf. So this is a typical kind of rate that's used to try to improve organic matter in the soil, a better turf overall. But when we calculated how much phosphorus that was available phosphorus that was actually putting on, a 1/4 inch was about 1,300 pounds per acre of available phosphorus, and double that if you put a 1/2 inch on, where again our typical fertilizer rates that are about 1/10 of that. So you might expect, if we're putting on these extremely high loads of phosphorus, that you could have a potential for phosphorus runoff. So this is what the actual plots look like, and if we did the same kind of study that we showed earlier that Doug did, in this case, these are the ones we had that we didn't put any compost on. They were down less than 50 pounds per acre of available phosphorus. But once we start putting compost on, you can see we could elevate these levels up to 500 pounds per acre, and the amount of phosphorus in the runoff significantly went up. And so to me, there is a big concern about using landscape areas that with high rates of compost application, especially if there are nutrient-rich ones, which are typically dairy or poultry or other animal-based ones. And so there are 2 issues with that. One, that you can saturate the soil's ability to retain phosphorus, and you increase that risk of phosphorus runoff pretty significantly. And the second part is there's another kind of ecosystem effect that is going to be depressed, as you're going to suppress the carbon and nitrogen sequestration you would typically get in an area with less organic matter. And so when we start loading up our landscapes with compost, 2 things could happen. One, if there are nutrients in those composts, you could run the risk of a lot of phosphorus runoff, or you're certainly going to reduce that site's ability to sequester both carbon and nitrogen if you have a tremendous amount of both those. Matter of fact, they'll probably be losing those as that compost degrades and mineralizes. you're going to see carbon and nitrogen being released out of that system. You're not going to really retain very much other than if you have above ground plant parts there. So the last part I want to cover on this ecosystem part is carbon and nitrogen sequestration. And I worked with Steve Rossetti. Steve was a PhD student over in natural resources. I happened to be on his committee because he was doing turf work, so I thought that was kind of cool. And now he's currently an assistant professor at Hofstra. Went to BU for Boston University, that BU, for a postdoc when he left here, and then he has a university position. So what did Steve do? Well, Steve was working in the Baltimore ecosystem study, long-term ecosystem study area, and he took soil cores out of residential areas and forested areas. There were 32 residential sites he worked with and 8 forested sites. Again, those forested sites were from the Baltimore ecosystem, their long-term ecosystem research studies that they've been doing in this site for a number of years. And the ones coming from the residential areas were primarily lawns with cool season grasses in it. And there were a few trees and shrubs in the area, but the primary landscape feature where he was sampling was from lawn areas. And so he took 1 meter deep undisturbed cores, broke them up into 4 zones, and looked at total nitrogen and carbon in those samples, and by knowing the bulk density, then can relate back to an amount on an area basis. So what did Steve find? Well, he found, comparing residential to forested, that there was more carbon stored in those soils in residential and nitrogen than forested areas. The amount of the carbon-nitrogen ratios were similar in those, but the absolute amount of carbon in the residential soils, lawn soils, compared to the forest areas on the same soil series were significantly higher. There's a time sequence in that. He had sites that were as young as 5 years, and the oldest one was about 45 years. And he saw this kind of linear accumulation of carbon over time and nitrogen over time in those residential areas. Now, it would have been nice if he would have been able to go out another 40 years or so to see if this continues, but there definitely was over time and a fair amount of sequestration of both carbon and nitrogen in these residential soils. The difference occurred primarily in the top 70 centimeters of the soil. We can see with carbon, the 10 to 70 centimeter zone, this is where the major increase, significant increase occurred compared to the forest soils. In nitrogen, it's the top 70 centimeters, even at the surface 10 centimeters, that had higher in the residential area than the forested area. And the percent carbon was slightly higher, again, in the residential area than in the forested area at most depths, except for the deepest sample. And so we did a mass balance in these areas, and kind of adding that up, he was able to conclude from this, and I'll put his concluding statement up here, that these data suggest that soils in residential areas on formal agricultural land, so these were suburbs that had taken farms over, had a significant capacity to sequester nitrogen and carbon following development. In this case, they had data for 45 years. Given the large area of these soils, they are undoubtedly a significant regional carbon and nitrogen balances as a form of sequestration. Okay, perfect. Final thoughts after 35 years being here, plus. This was my first seminar 36 years ago in December. And Bill, this is what I want to point out. You see this rose? I had a rose tie on. When I came in, the department I was in, floriculture and ornamental horticulture, a lot of rose guys. So I think the reason I got this job is I had this tie on, Bill. Jeez. Most people have not seen me without a beard, so this is pretty cool. And hair. Those are two good things. So those of you young faculty that want to complain about startup costs, this is what you got back in 1979. I got a $5,000 Hatch grant. With inflation is now $17,000. The dean said 2 years ago the average startup package for a faculty member in Cal's is over $800,000. Okay, so you young faculty think you have it hard. No technicians, no postdocs, no grad students, a whopping $5,000 a year and $17,000 in today's funds. So just to remind you people. Okay, when I first came, we had mainframes with punch cards. There were no PCs. Smartphones, we didn't even have. I had a party line phone with 2 other faculty members and extension with a light on it. So when that light was on, somebody's talking on the phone. So a guy, George Good, who was a nursery landscape person, more than 50% extension. I was 50% extension. And Bob Kozlowski, who was 100% extension. It put 3 of us on the same line. It was a fight. Every time that light went off, everybody was grabbing for that phone. So technology has changed over my career. But I want to thank people who I've worked with over the years. My first technician was Ron White. Some of you do know Ron. He was a phenomenal engineer. He was a turf guy, but he was probably the best engineer I knew. John Gowan, Chris Sanchirico, Howard Piddick, Jeff Barlow, my current technician back there. I left Alexis Hines off this list. She was an asset for a good asset for a couple of years. Then some of my previous colleagues, Norm Hummel was here on the faculty, and Joanne Gutaderia, who we still hire from time to time. Some more current ones, and I don't have a picture of Jenny and Kyle Wicken, but some of our people such as Frank and Jennifer Grant in the middle here, and field staff and other IPM people. It's been kind of great, working with everybody. But the grad students are always the best, and this is the list that I was able to work with over 35 plus years. They were good things. So here's a Just Grass, hopefully maybe a little bit more. So with that, thank you. New Jersey is the most recent one. Pennsylvania is right in the middle, but I don't know whether they've passed theirs. New Jersey is called the most restrictive, but they all have that, at least for phosphorus, have that similar problem. Connecticut didn't do it. There were kind of 2 things in these laws that were done. One, that they exempt organic fertilizers, or fertilizers that had come from compost. That's one of the other kind of caveats. And it's like, excuse me? Eventually that phosphorus or nitrogen is going to be released out of those. And so it was mostly, that's the politics. They're saying, well, we produce, especially municipally, produced all these composts. What the heck are we going to do with it if we ban it? Because they all would be banned under the definition. So they decided, okay, maybe there's not really that much used, and it may not be a big problem, but New Jersey, I think their law is pretty good, but they all have a little bit of twist to it, unfortunately. That's why I wish Frank were here. Actually, Frank has done some of those studies. Yeah, his work, and he was looking mostly from a golf course perspective, which is probably one of the most intense ones because of mowing and inputs. And so there is net accumulation, so that even though you do have to mow them, you have fertilizer, you have irrigation, all those those carbon versions, they do get the net accumulation is greater than those inputs. So it's outweighed by those. And it's an area that I think somebody should do a lot more work in, but that when you had to look at the bigger picture. But Frank had done a little bit of that work. Well, it's a great question because the next study that was done, we're finishing up, did that. We kept the traditional high input Kentucky bluegrass version. We looked at low maintenance grasses, tall fescue and fine fescue, with and without clover in those. So that was like only maintained organically with organic products. So that's the next generation of these things. And the take home is after a while, they all perform very similarly. The losses they end up being low because you do have an establishment. If you take that establishment period out, once you get density with these things, and actually in some of the years, because we have 3 years, and I haven't seen the 3rd year, but in some of the years, actually the low maintenance fine fescue with clover was the worst for losses. And I don't know whether that's just an aberration or if that's real. But if anything, the high maintenance one was not worse than those other landscapes. But that's been the other a lot of times you'll see regulations kind of written around that. Use low maintenance grasses, and it's not always the maintenance that's the issue. It's the density and what it does to really the hydrology of the system. If it changes that, it can outweigh some of the potential negative things. And there is a period. The nitrogen. I mean, turf is a good nitrogen sink. Phosphorus, it really depends what the soil levels are initially. And if you put it on at a time when the soils are wet, you could get a lot of phosphorus runoff. I mean, there's a management component to that for sure. Good. So that's probably it. I don't think I'm going to give another seminar, Don. Thank you. That is a more important one. Thank you.
This has been a production of Cornell University. On the web at cornell.edu.